Alright, so we're going to pick up where we left off in the previous video, which we left off at this section 1.3. It says z-scores for hypothesis tests. Really, it's we're going to talk about t-scores and chi-square scores as well. So throughout the course, we've been using charts to find areas under curves, right? Because with irregular curves, we can't do it algebraically. We need calculus to find area. And so those charts are basically where the calculus has been done for us, and they just gave us the answers that we need. So, of course, you know, working statisticians don't use charts. They're going to use some sort of statistical package like R to do those area calculations for them. And so, just as a simple example, let's suppose that we're doing a hypothesis test where we're doing a right-tailed test in which we have a test statistic 1.99. Then, you know, we can find the area to the right of that test statistic, or in other words, the p-value, just by plugging this into R, right? So this function p-norm, or probability for a normal variable, is going to give us the area. There's a small error here, which is that it says left tail equal to false. It should say lower dot tail equal to false. So let's go ahead and type that in. The p-norm function defaults to the left to the lower tail, and so if we want a right-tailed test, we then have to tell it, hey, I don't want the lower tail, I want the right-hand tail, right? So that's what this little code does, is it says, instead of using the default, use this other setting. Okay, so p-norm of 1.99, that's our test statistic. And then we're going to have lower dot tail equal to false, and you do need all caps there. And there you go. So this gives you the p-value, right? P-value is the area that's at least as extreme as your test statistic. So we have a p-value of 0.023, and so if we were doing this test at a 5.05 significance level, we would reject the null hypothesis, right? So draw in a normal distribution and draw in what this hypothesis test looks like. Make sure it's in the right tail. Make sure that you illustrate the shaded, shade the region to the right of 1.99. Illustrate what area is to the right of 1.99, and state whether you would reject or fail to reject based on that p-value. All right, so we can certainly compute p-values for t-scores and chi-squared scores as well using R. And that's kind of nice, because if you think back to the charts that we have, the only chart where we can compute probabilities accurately is with the z-score chart, right? Because given any z-score, you can find almost exactly how much area is to the right and to the left. And so you can compute areas or probabilities very well with the z-score chart. But the t-score and chi-squared chart, you're much more limited. They only offer a couple of different areas, and they tell you, here's the t-score that has that amount of area in any given tail. So the t-score chart says, if you want 5% of the area in the right tail, here's the t-score that gives you that much area in the right tail. So it's much more limited. And R is then going to allow us to compute p-values associated to any t-score and any chi-square score. Okay? So the pt function is basically the analogous version of p-norm, but for a t distribution. Okay, so probability for a t variable. So same deal as before. It defaults to the lower tail, and so let's go ahead and calculate. If this is our t-score, our test statistic, then this t-score with df equal to 9, degrees of freedom equal to 9, is going to give us, or sorry, this pt function here for this t-score is going to give us the area to the left, because that's how it defaults. So let's type that in. And so there you go. To the left of this t-score with that degrees of freedom is 0.075. So if we were testing a hypothesis at the 0.05 significance level, we would fail to reject because this p-value is larger than the significance level. Okay, suppose that we're actually doing a right-tailed test. Well, we know that it defaults to the lower tail, so if we want to do a right tail test, we would say lower dot tail equal to false. Again, there's that error there where it says left. It should say lower dot tail equal to false. And that'll give us the area to the right. So probability for the t-distribution with this t-score, 9 degrees of freedom, and lower dot tail equal to false. And so it tells us that there's 0.924 worth of area to the right of that t-score. Okay, so it's as simple as that. We're just going to run a couple of hypothesis tests here, and just using this new skill that we have. So suppose we want a left-tailed test with a t-score of -2.29, sample size of 12, significance level 0.01. Okay, so let's go ahead and compute that, and then I'll have you guys do this one on your own. Okay, so the p-value, be real careful here, it's a left-tailed test, so that says take your test statistic and find the area in the left tail that's to the left of that test statistic. Okay, so we know that to compute p-values, you just do pt test statistic -2.29. Sample size is 12, so degrees of freedom is 11. And so there you go. That gives you a p-value of 0.021. Since that p-value is larger than the significance level, we would fail to reject the null hypothesis. Okay, so go ahead and run through that same procedure for this example, and the chi-squared distribution, you can also compute degrees. You can compute p-values in R using this command, p chi-square. And so same deal as before. The chi-squared function on R defaults to the left tail, and you should note that that's the opposite of what our textbook does. Our textbook gives us a chart in which it gives us area to the right, so R is backwards from what the textbook does. Okay, so let's go ahead and just try this out. P chi-squared of this says this is our test statistic that we computed, this is our degrees of freedom, and it's going to give us the area to the left of that test statistic. Okay, so very, very small area. That E -06 says take that number times 10 to the -6th power. So very small number. Okay, 0.000001 basically. So very, very small p-value, right? And so in this case, clearly that p-value is going to be small enough to reject the null hypothesis. Okay, so why don't you guys run through this next hypothesis test here. Again, that says left tail, but we know it's supposed to say lower dot tail. Okay, so run through that next hypothesis test. All right, now section 1.4 is on loading data. This is a very important section. Okay, so far we've just typed data into R, right? We just, any data that we needed to load, we just used the, X is going to be assigned this combination, 4, 5, 8, 12, 3, right? And so we just typed everything into R. But usually there's too much data to load by hand, and also that can be error prone as well. So usually we want to import data from some source. And so we're just going to do a very simple example of this to start. Let's go ahead and open up Notepad, some simple little text editor that doesn't have any extra formatting. Okay, that's really important. You want to use something simple. You don't want to use Microsoft Word or OpenOffice or anything like that. Use Notepad, because what it does is it saves everything with no formatting. And that's important so that R knows how to locate all the data in this document. Okay? Alright, so let's go ahead and open up Notepad and type in this random string of numbers here: 54, 21, 43, 19, 51, 39, 50. Okay, so there we go. Let me just double check everything's entered correctly. Alright, so it looks everything's correct there. And what we're going to do, we're going to store this in a very convenient place. And so I'm going to go File, Save As, and then I'm going to go to this PC here. So I'm going to open up basically the My Computer option, C drive, and then I'm going to create a new folder. Okay, so I'm going to right click, New Folder, and I'm just going to call it R. Okay, so it's very important that you choose a convenient place like this so that you can easily locate the data when you want to move it into R. Okay, so I'm going to open up the R folder that I just created, and make sure that you type all this stuff exactly the way you see it here. Okay, so we're going to call this column because we have one column of numbers. Okay, so we're going to call this column, and it's going to be saved as a .txt file. Okay, so column, and it's going to be saved as a .txt. Okay, so there you go. We now have this saved on the computer, and this is outside of R, right? It's just a random file sitting on the computer. So what we're going to do is now we're going to learn how to load it into R. Okay, so the command, you'll get used to it pretty quick. It's pretty easy. We're going to create our first table. Okay, so that's going to be our variable name. First dot table is going to be assigned. Now this read.table is the command that tells R, hey, go out into your computer and find this data source. So this is a very special command that R uses, and then it goes into the computer to look for this. Okay, so we're going to do read.table quotes C:/, and just to be on the safe side, I'm going to use all caps where it shows caps on the document, and all lowercase where it shows lowercase. Okay, so there we go. Just typing in everything exactly the way I see it on the screen, and I highly recommend that you do the same. Use the same caps. Make sure there's no spaces where there shouldn't be. Make sure there's no commas where there shouldn't be. Everything has to be exactly the way you see it, and if you don't put it that way, you're probably going to get an error, or it may read things improperly, something to that effect. And so just make sure you're very, very careful when you type this stuff in. Okay, so hit enter, and there we go. Once again, if it doesn't tell you any errors or anything like that, that means you did it correctly. Okay, so we've loaded our first data. Alright, and so let's go ahead and take a look at what this consists of. And so we just type first.table, hit enter, and there's that column of data that we were talking about. Okay, so go ahead and write out first couple of values that R shows you here, so I can see that you did it right. Alright, so in this column you'll notice that we have a whole lot of data points that we may want to access individually, right? So let's go ahead and type in this command here, first dot table 3 comma 1 says go to the third row and tell me the first item in that third row. So it's 43, right? So how would you do the fifth row first column? Go ahead and write that in there. How would you do the seventh row first column? Write that in there. And also tell me the output that it produces. Okay. And then, of course, R has the ability to manipulate data, right? We can add it, subtract it, do any operations that we want to. So first dot table 1 comma 1 plus first dot table 2 comma 1 gives us, so there's row 1 column 1, row 2 column 1. So it's just going to add row 1 column 1 plus row 2 column 1. Those two values add to 75. Okay, so write that in there. Okay, so what we're going to do is we're going to load some real-world data in here. So go to My Etudes, and just in case you haven't been to Etudes, let me show you what it looks like. So go to myetudes.org, user ID, type that in. It's going to be your student ID number without leading zeros, okay? And then the default password, or if you've got your new password, then type that in. Okay, so here's Etudes, and you'll just click on our class, Math 13, Fall of 13, and go into the Resources tab, okay? And it says all this stuff in the project. Okay, go to Resources, and there's this file called table.csv. Okay, so let's download table.csv. And this is the Dow Jones historical prices. Okay, and so currently it's saved in the downloads folder. So let's see. There it is. Okay. So I'm going to take this and cut it, and then I'm going to go paste it into my new R folder. So just paste that file right here. Okay, so now we've got that loaded into the R folder that we're going to use to hold all the files for the project. Okay, so there's all the data. You can see you definitely don't want to do anything with this data by hand. You have to use R to load it all in there, right? So there's the data, and now let's go ahead and load it in there. We know the command is going to be, so we're going to do stock.history is going to be assigned read.table c:/r/table.csv. Now again, I'm following all the capitalization and all the slashes exactly the way I see them here. Notice this comma. Do not forget the comma. Space sep equal to. So that means how is this data separated? How can we tell when one data point starts and another one stops? And this data is separated by commas. So we put sep is equal to comma header equals true. That just means that there's a row at the top with some labels. And so when it says header is equal to true, it knows that that first row in the data set is just some labels, and it's not actually part of the data set. Okay? Alright, so it had to think there for a second because there's so much data that it had to deal with. And so after it was able to load all that data, it just gave us the new line here, and since we didn't get an error, that tells us that everything's fine, right? Okay, so go ahead and type in the next couple of commands. Okay, run through these little questions here. Now, what you'll notice is that it gave us tons of data, right? And we don't want all this data, right? We're just going to look at the closing price, okay, which is the 5th column. Doesn't show it on here, but one of the labels at the top of this data set is close price. And so you'd look at that 5th column, you see the 5th column has the closing prices. So this command here, what it's going to do is it's going to say, I don't want all this data, I just want the closing price. So I'm going to do close.price is going to be assigned stock.history, comma 5. So stock.history is where all of our data is loaded currently. This says give me every possible row. Since I didn't specify a row, it's going to give me every possible row from the 5th column. And so when you hit enter, it takes that 5th column of data and plugs it into this new variable. Okay. So we can start doing stuff with this now, right? So how many data points do we have? Length tells you how many items are in that list. So just type that command in and write out the answer. You can find the minimum closing price, so you'd write that, do that command, write the answer there. You can find the maximum with this command, and you can find the percentage increase by doing high minus low over low times 100. So that's if you bought at the very low and sold at the very top of the stock market, what percentage would you have made? So that's a pretty interesting question there, and you can try that out. And here we're going to do a little plot. So one thing I want to point out about that plot is that the way this data is loaded, it's loaded in reverse chronological order, so that this is back in the 1920s, and then you get more recent as you move to the left. Okay, so just a little comment there. Okay, so there we go. I'm going to leave it here for this segment, and we'll pick up the rest, this very important next section in the next video.